Ask me
My
though.
mom told me that she fired my daughter American Girl dolls and whatever's. Oh, we got more of the accessories.
Uh, oh my God, did you see that? They make a science out of it there.
Great.
Wow. Okay, ladies and gentlemen. Here's what we have. Question number one, guys. You have it right in front of you, right? You have all this information on the sheet that I gave you. Everybody can see that? The sheet that you got, guys, have all this info. It's a floodlight problem. The floodlight problem, guys, have coefficient to visualization 90% atom, coefficient to beam utilization CBU 44%, um, light lumen depreciation factor 70, light dirt depreciation factor 85, lumens 30,000. It's a floodlight. The area that we need to flood with this light is 20 by 20. And the question would be very simple. You're given all this information. Do you see it right there in that sheet that I gave you? You're given all this info. May you please find me the average foot candle, the foot candle. Can you see what we're going to find? Everybody's good with that? Shall we go do the foot candle? Okay, here's the formula that you need. Please bring the formula with you. The formula that you need for this one, Adam, is the lumens multiplied by CU multiplied by CBU multiplied LLD, divided by the area. Right? That's a very simple formula. Then all what you have to do, gentlemen, ladies and gentlemen, is put the numbers in. You put your lumens and you multiply by 0.44. Coefficient of utilization. Oops, let's start one by one here instead of. So you multiply by all these factors. You need the 0.9 coefficient of utilization. Beam utilization is 0.44 multiplied by zero point 0.7 is LLD, and LDD is 0.85. And when you divide everything by 20 times 20. That's the area. And gentlemen, your average foot candle will equal 18. Now, how easy that is. Like I said, if you want to memorize the formula, great. If you don't want to memorize the formula, please bring it on a piece of paper and plug it in. That's it. That's the floodlight formula. Any comments, guys? Any questions about it? Very simple, very easy. All the information right in front of you. Plug and play. So that's question number one. Cool. Floodlight. Let me know when you're good with that. There is no reason, guys, not to ace it. It really is. The only thing that could happen is a calculation mistake. How do you do this with a scientific calculator, Adam? You multiply all of them between brackets, and then divide open brackets and 20 times 20. You guys know how to use scientific calculator. You know, multiply the top, then divide it, open brackets, and that's how you put them in. Cool? May I move on? Good? Okay. That's question number one. Question number two, gentlemen, ladies and gentlemen, it asks about room cavity ratio, ceiling cavity ratio, and floor cavity ratio. It's telling you guys you have an area of 70 by 300 by 12. So length, width, and height. The 70 by 300 by 12, okay? And we need to find RCR, CCR, and FCR, room cavity, ceiling cavity, and floor cavity. Now, I want you guys, it says C graphic, right? Here's how here's how I'm going to divide the cavities. You have to tell me how you're going to divide the cavities height, because I have no idea how you're going to divide them. If I just tell you this without giving you guys this graphic, you have no idea. Chad, tell me how you're going to divide your cavity. So here's what you're going to do. I would like my floor cavity to be up to 2.5. My ceiling cavity height, I would like it to be 7. And the rest, the leftover will be 2.5. That will be my ceiling cavity. I have to tell you this, okay? So on the test tomorrow, guys, use this criteria to divide the ceiling and the floor 2.5, and the leftover will be for the room cavity, okay? Everybody understand that I want you guys to draw this tomorrow on the test. Use 2.5 for the floor, 2.5 for the ceiling. The leftover will be for the room cavity. So Karen, that number, the height might be 15 tomorrow. You just take 2.5 from here, 2.5, and the leftover will be for the room cavity. Everybody's cool? Everybody's good with that? I know it's Monday morning after Thanksgiving. Too much turkey. I ate too much turkey. The rest, guys, is piece of cake, huh? Okay, everybody, the most important thing, guys, please tomorrow draw the cavity height, the height of the cavity. So the height of the cavity, you can see number 1 is the room, number 2 is the ceiling, number 3 is the floor, and the height I am telling you, Adam, otherwise you wouldn't probably know. I'm telling you the height, I want it to be 2.5 here, 2.5 here, then it would leave me with room cavity of 7, okay? So the next is, let's go find these 3 things. Okay, here's the formula that you need, guys. You need, bring this formula with you, 5 times the height multiplied by the width plus the length divided by the width multiplied by the length. The first thing you need to find is the height of, this is a room. The height of the room cavity, guys, is 7 feet. That's the first thing you need to find. The height, HR, is the height of the room cavity. Then, plug it in. So here's 5 multiplied by 7 multiplied by the width and the width 70 plus 300 given to you guys divided by 70 times 300. And if you guys did that one, that will get me a 0.6, which approximate to number 1, so we can get it from the table. So if you stopped at this tomorrow, Karen, if you stopped at 0.6, that's good for me. But typically you take it to the closest whole number, because we don't want to do interpolation. Is that hard, guys? The common mistake is to find the height of the room cavity ratio. I want to remind you guys, when this is for the this is for the room cavity ratio here. That's what we're focusing on. So I want to focus on the height here is for what? For the room. HR is height for the room. That's number 1, piece of cake. Let me know when you're ready for. Now you can imagine the others will be the same, except the height will be changing, right? That's it. Now tomorrow, our IES NA at Twin Cities guys will be talking about these topics, the lighting and calculation by hand. I gave them a couple of things to focus on. They're not going to walk you through the calculation by hand, but we'll tell you what to focus on if you want to be a certified lighting designer, which means you'll have a good job and hopefully a secure job. Let me know when I can move on. May I have thumbs up, thumbs down, move on, Chad? We're good? Okay. All right. The second one, guys, is find the CCR, which is the ceiling cavity ratio. The most important thing, Adam, for the ceiling cavity ratio is to find HC for the ceiling cavity ratio, which is 2.5 feet. Then you plug him into here, same thing, 5 times 2.5 times 70 plus 300 divided by 70 times 300. And let me put the height somewhere. So I'm going to put the H ceiling equal 2.5 feet here. Then if you guys do all the math for this, 0.22, and that approximate to big fat fluffy 0. So that's again, if you for tomorrow just put 0.22, and that's good enough for me. That's your ceiling cavity ratio. Ceiling cavity ratio. Makes sense? Yes, no? You guys have the review in front of you too. I'm gonna go ahead and do the floor because the floor is exactly the same. For the floor, guys, I'm gonna put the IR for the floor, the height for the floor is also 2.5 feet. Then we're going to plug it. You're going to find it's all the same. Times 2.5 times 70 plus 300 divide by 70, not 700 yet. 70 times 300. All this will get you the same number, 0.22, approximate to big fluffy zero. Same calculation, right? If the height is the same, guys, the answer have to be the same. Same formula. Okay. Now, on the test, guys, I will give you a height that's different for each one of them. Any comments, guys, about this?
Well, I think you said on the testing one, the CC on the NCR does be 2.5. You gonna change that up?
Yeah, I could change it up. I really didn't look at the test. It could be one of them is 2 and the other 3. Would it make a difference? And not really. If you guys give me a thumbs up when you want to move, say move on, chat. Move on. Good, good. Adam, Karen, good. All right, so last question, gentlemen. Question number 3. You guys have all this information right in front of you. Let me go over it. You have a room of 50 by 60 by 13. Okay? Room 50 by 60 by 13. Width, length, and height. Okay? Cool? Width, length, and height. And I am, whom I want to pick on? I'm going to pick on Karen. Karen, we hired Karen to do the lighting layout. She picked 2x4 fluorescent, the most common type of fixture. She used 2x4 fluorescent. The lumens of each one of these is 400. Each one of them has a 2-lamper, small number of lamps. The foot candle required is 90. The light loss factor is given 70%. The reflection of the wall, all this, guys, is written right here. The reflection of the wall is given a reflection of the wall and the ceiling and the floor. Floor, ceiling, and wall reflection, they're all given as 20, 80, and 10. What I would like you guys to find is the following. Number 1, the room cavity ratio, ceiling cavity ratio, and floor cavity ratio. Number 2, coefficient of utilization. Number 3, the number of fixture, and number 4, the layout. The number of fixture, and number 4, the layout. Could you please add the layout? I don't think I have the layout. Number of fixture required in it. Add number 4, which is the layout. So we're going to go find how many fixtures do we need based on this criteria. And then, and you have to have the coefficient, the room cavity ratio, coefficient of utilization, number of fixture, and layout in this order. Otherwise, you can't do them. You have to find one to find the other. Any comments, any questions, guys, about this? The only thing that's missing from this equation, Karen, is how do you want to put your light, Chad? What's the height of the cavities? I have to tell you the height of the cavities. Okay, so if you guys look at this, any question about the given? So, any question about what's given for you? Okay, room cavity ratio. So make sure you guys go to page 84 in this book, page 84, because we need to find the coefficient of utilization from there. So we find the floor cavity, floor reflection, and ceiling reflection, and wall reflection. Okay, so let's go ahead and plug them in. All right, the first thing I need to know, the first thing you guys need to know from me is how are you going to mount this fixture? Here's what I'm telling you. The fixture is going to be mounted in the ceiling, and I need you to find the calculation at the floor level. So from the get-go, guys, height, the room cavity ratio height, if I mount the fixture right in the ceiling, surface mounted or recessed, and I need the calculation to be done right here on the floor, that's what I'm telling you. Then the height of the room cavity is 13. Can you guys agree with me that the height of the ceiling and the floor is what? 0, 0, 0. There is no height of ceiling. The whole cavity is room cavity. Okay? That's how I want you to do it. Well, like exactly like this one here, right? Nothing above it. It's not suspended. And from here down, instead of having it at 2.5, I would like you guys to do it like always at the 0 level. Okay. Can everybody understand what this is? I have to tell you tomorrow that that's how we want it to be mounted. So the height of the room is 13, which is the height of the room cavity is the same as the height of the room. Plus the ceiling and the floor are 0, 0. That's from the get-go. That's from the get-go. Okay, then let's go find the room cavity. For the room cavity, guys, I want to go directly find, here's my formula for the room cavity. You take 5 multiplied by 13. Everybody knows why 13, because that's the height of the room cavity. Multiplied by 50 plus 60. That's the dimension of the area. And divide by 50 times 60. And if you guys did your math, you're going to end up with 2.4, and I'm going to go approximate this one into 2 so I can find the value. That's my coefficient of utilization, my room cavity ratio for this particular room, It's 2.4, and I went down to 2. You always go to the closest, right? 0.5 go up less than 0.52 unless you do interpolation. Okay. Now, ceiling cavity ratio, if I ask you about the ceiling, guys, here you go, 5 times big fat 0 multiplied by the same thing, 50 plus 60 divided by 50 times 60. And you agree with me that this is also 0. And also, right underneath it, the floor cavity ratio equals 0. Can you guys see that? Why these 0? Because the height is 0. We learned this one long time ago, guys. If you multiply anything by 0, you get what? 0. So the ceiling and the cavity ratios are both zeros. That's fine. But I want you to write that, though. On the test, if I ask you, assuming no ceiling cavity ratio and floor cavity ratio. If I say assuming no ceiling cavity ratio and floor cavity ratio on the test, this means both of them are 0, and the height, this is what this assumption will give you. The height is 13. You'll see this on the test. Okay? I just did these, the ceiling and the floor, just so you know it's 0. So we're assuming. When it says no room or no ceiling cavity ratio, meaning we don't care. We're mounting it like this one in the ceiling, and we're shooting it not at 2.5 level, we're at the floor. Any comments, guys? Any questions about this? You can see where my fixture is shooting right in here, the light. Okay, now we found the first thing, which is room cavity ratio. Can I move on? Yes, no, Chad? Okay. So let's go next to, we need to go next, guys. Go to Fig 10.3, page 84. Now tomorrow, Derek, open the book. When you reach that one, you know that's the one I'm going to use, and make sure you know how to use it. Okay, based on the following. The floor room, can you guys go verify that you know how to use it? The floor reflection is 20, the wall reflection is 10, and the ceiling reflection is 80. Okay? Ceiling reflection is 80. Can you guys see that? And coefficient of utilization. What did we come up with the coefficient of utilization? We came up with the room cavity ratio. We came up with room cavity ratio 2. Don't forget that room cavity. Based on all this information, can you guys verify, what did you come up with, Karen? 0.59. Thank you. So make sure this is 0.59. 0.59. Everybody knows how to use this table. Please go where the floor is, where the wall, where the ceiling. Can I have thumbs up, Chaz? Because if you don't know how to use it, you're going to get the wrong number. Okay, so based on the floor, the wall, and the ceiling reflection, and the room cavity ratio that we have just found, Adam, you're going to come up with coefficient of utilization of 0.59. Cool? So just go, guys, to that particular page and pick that number. Okay, so now we found the second thing, which coefficient of utilization, CU. The last one, gentlemen, or the one before the last, am I doing too fast? Derek, does it make sense?
Yeah, good.
Good? Yeah. Good. Adam, Karen, good. Okay. So that's just directly knowing how to use the table. Please let me know if you don't know how to use it. Now the next formula, the number of fixture, here's the formula that you need, guys. Foot candle multiplied by the area divided by lumen, lamps, and LLF and CU. Okay, now all this information is given, Adam, so I'm going to go plug them in. So I have 90 foot candle multiplied by the area of 50 times 60. That's my area. Divide everything by 4,000 lumens out of each lamp. I have two lamps, and the coefficient of light loss factor is given as 0.7, and coefficient of utilization, I found it as 0.59. Can you guys see how important that is? Because we see you plug it in right here. Can you see it with the coefficient of utilization? If you guys came up with this number, you'll end up with 81.7. Typically, you go to 82 fixtures. 82 fixtures. So how many fixtures do I need based on this design? 82 fixtures. A lot of fixtures in an area like this. 82 fixtures. Any comments, guys? Any questions? The only mistake that you could make is calculation mistake. Have your formula handy. Plug them in. Not a big deal. Now, we need to find a layout. We found the fixture. We're going to lay them out. Cool? Everybody's good? Good, 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 good. Okay. Let's go to the layout. Now, do you remember how we talked about when we do layout, guys? You do the factoring. So I have 82 fixtures. 82 fixtures. Ask yourself, Adam, what are the two numbers that you multiply by each other, largest numbers, to get 82? Okay. I have a 41 by 2 or 82 by 1. Right? These are there any other option to get 42? 82? 41 is a prime number, so you can't, right? 41 is a prime number. 2 is a prime number. So you really, so here's your option. Either you make 42 rows and 2 columns, or 82 rows and 1 column. Are you kidding me? 82 rows and 1 column? So that distribution, Adam, is not the best distribution, right? Either way. So here's what I would like you guys to kind of, then you use your judgment. There's multiple ways of doing it. I'm going to go and make an executive decision and change this number to 81. So I just dropped one fixture, Karen. Okay? Not a whole lot, just one fixture. Anybody knows why I made the pick the 81? Okay, if you have 84, what would be the multiplier for it then? Four by 21. So we'll have 4 by 4 columns and 21 rows. Really tough. They're too far. So see what I mean? If you do that one, by the way, I'll give you full credit, either whatever you're doing the test. But you want to try to find a number that can get the rows and the columns as close as possible. For this one, we're lucky because 82 is very, very close to 81, right? And we all know what 81 is, right? Anybody knows why I picked up the 81? 9 times 9. Perfect distribution. Now, guys, on the test, use your judgment on that one. Make it as close to a square as you can. But if you did what you said, Karen, I'll give you full credit. The layout. That's kind of judgment. I used 9 by 9. That's perfect distribution. 9 columns, 9 rows. Okay? 9 columns, 9 rows. Okay, so that's how my distribution is. I dropped one fixture though, but remember it was actually less than 81, right? It was less than 82, it was 81 point something. I dropped it down. Okay, then here's your layout. The layout, guys, is 9 by 9. 9 by 9. And in the center of every fixture, in the center of every, you divide it into 9 columns. Can you guys see that? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns, 9 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns, 9 rows. Perfect distribution. Perfect distribution. Now, the criteria, guys, that you can use, or one criteria, is the distance from the wall to the center of the fixture is half the distance between the two fixtures. That's the rule. Okay? So now I need to find the x. The x is from the wall to the center of the first fixture, and the y from the other wall to the center of the first fixture. Okay? So here's how I put x here, x, 2x, 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 x. Okay? The same thing here, y, 2y, 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 all the way to another y at the bottom. But I need to find y and x so I can center my fixtures. Here's the easiest way to do it. For the x, let's do it for the x, okay? For the x's, can you guys see the x's is this way? So for the x's, how many columns do we have? Can you guys see how many columns do we have? For the x's, how many columns do we have? To find the x, 1, 2, 3, we have 9. So you take 9, multiply it by 2x equal, what's the x here? 60. One more time. If you count them, guys, they'll be the same. If you take the number of columns that you did, which is 9, multiply them by 2x. Why 2x? Because there are 2x everywhere, and if you add that one here and that one at the end, will make another 2x. So that will make 9. 9 2x's. So 9 is the number of columns multiplied by 2x, because the distance between them 2x, and the one at the end here and here together, they make also 2x. That's all you have to do. The alternative is what? Add 1x plus 2x plus 2x plus 2x, blah, 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 and that should give you the same number. Okay, so if you do this equation, guys, what would that give you? It'll get you 18x equal 60. 18x equals 60. And x equal 60 divided by 18. And that should give you an x equal 3.3 feet. 3.3 feet. Now, I understand that you might not go to 3.3 feet. Later on in the field, you might adjust it to 3 feet or what's not, but that's your start point. Okay, so the distance, guys, between the wall and the center of the first x is 3 feet, which makes sense because that's 2, and that will give you 1 foot here. That's typical, 1 foot. See that 1 foot to the center, Adam, not to the edge of it, to the center. Okay. So that's the x between them. The y, can anybody tell me what the y should be? I'm going to put the y right here. Okay, I'm going to put my y, oops, before we do the y. Can you guys anybody can give me the equation for y? I need 2y multiplied by a number. So for the y, guys, for the y's, which is this way, how many rows do you have? 9 rows, so multiplying by 9 times. How many y's? 2y equal, what's the distance? 50. And gentlemen, that will get you 18. From here you get 18y equal 50. And I don't have room here, so I'm going to move it up to here. And then y equal 50 divided by 18. And that will get you 2.8 feet. 2.8 feet. The y is 2.8 feet. Does that make sense? Y is 2.8 feet. That's it. So you go from here, where we 3.3 from this wall to the center of this, and 2.8 from this wall to the center of that one. Now, what's the distance between the two fixtures? If I ask you guys, what's the distance between two fixtures? You take this number, the x, and multiply by 2. That will be 6.6. What's the distance in the y, between two fixtures? You take 2.8 multiplied by 2. That will get you what? 5 something? 5.6. Any comment? I'm asking you about the x. What the x and what the y? What's the distance between the fixture? Please multiply by 2. That's it. If you don't want to multiply by 9, just go add them up. Add the x's. Because on the test, guys, you're not going to draw. And on the test, yeah. How are you going to do it, guys? If it's a big, all I want you guys to draw is draw something like this with x and y's. You don't have to draw all of them. And tell me where the x and where the 2x is located, the y, and how many columns. Sketch them and find me the x and the y, the layout of the fixtures, x and the y. Is that hard? So that's the supposedly the perfect distribution of your fixtures. And all these dots add up. These are the 21 fixtures that you're going to put in this area.
That's all you want is just one X and one Y.
I need the x and the y and the 2x's between. I want you guys to draw something similar to this. Not all of it, but show me how many rows and how many columns you have and where the x's and the y's are located. This will be PDF on the network too, if anybody want to look at it. It's not a whole lot of really to it. Any comments, any questions? So now so this is a good example, guys, how to use the room cavity ratio to find how many fixtures you need and lay them out inside the building. Lay them out inside the building. Any comments? Okay, the next part of the lighting test, guys, will be, how many did I say? 20? There will be 20 fill in the blank or answer whatever the questions from the back of the book. Everybody understand that one? These will be PDF answers, will be on the network. Please review them. And I'll pick the most important ones, put them on a test. So it's really, I know there's a lot of stuff in these chapters, Adam. The vertical and what's not, and they were doing a lot of calculation. I picked the most important ones that we need to know by hand. The rest now, softwares do all this calculation. We don't want to complicate it more than it's already complicated. Okay?